this video, we'll be building a hero animation for usage in web applications and websites using the Rive React runtime. In this case, we've got this interactive graphic here where you can move your mouse around and the view changes. You can click on planets, and there's a call to action to go to a different website, in this case, the Rive app website. So let's get started. So let's take a quick look at this Rive file and see what we're going to be working with. In this Rive file, you'll see that we're going to start with the hero demo listeners resize. And this is the artboard that's going to kind of serve as the backdrop for our website. If we play the state machine, it's very similar to what we saw on the website. You can still interact with these via listeners, but the main three inputs that we're going to be controlling with code are the numx, numy, and numsize inputs. These are all number inputs. And so, for example, if I scroll the numx and increase it to about 100, or scroll back down towards 0, you'll see that the view shifts on the x-axis. And similar to the y-axis as well, going from 100 back to 0. And these are all blend states. Now, the one interesting thing that we're also going to be playing with is this numsize input. Now, this is also a blend state. And as I increase the value, you'll see that the helmet size or view that we're looking through is getting narrower. And so you can imagine that maybe on mobile devices, we'll want this num size to increase based on the available width of the viewport. And so we'll take a look at how to use that at runtime. Now, to bring this file into our React project, what we're going to be doing is we're going to be exporting this Rive file. So if I click download in the editor, if I go to the download section, I can click for runtime.riv, download that asset. And now I've already included it, but you can drag it into your React project. In this case, we're going to be using a Next.js project, which is going to have a nice framework for us to build our React app on top of. And with Next.js, it has this public folder where I can include all my public assets like images or fonts. And so you can just plop it in there and you'll see how easy it is to reference that Rive file when we start using the runtime. The other thing we're going to do is install the React runtime project. But here's where you would npm install this Rive app React Canvas runtime. As of this recording, it's 3.0.52 as the latest version, but you might want to check the runtime docs to see what the latest version is as you're viewing this. So once you install this runtime into your project, and you've got the Riv file in your public folder or wherever you may host it, then you can start to look at building our React app. So we're going to go ahead and start here in our page component. This is kind of one of the main entryways into our web application. And so you can see here this home component that I'm exporting is mainly pretty simple here. It's just got this main tag with this Rive Hero component. And the Rive Hero component is where we're going to house most of our logic for what we're going to be displaying for our hero animation. You'll also notice that there's some of these class names like block and WScreen, HScreen. I'm using Tailwind CSS here to build the CSS, which is kind of like a utility library that can play along very nicely with Next.js. So if you want to see more of the inner workings of how the CSS is built up, you can check out the Tailwind CSS docs for that. But let's go ahead and get started into this Rive Hero component. So in this Rive Hero component, you'll see here that it's got a lot of logic referring to instantiating the Rive file and certain layout things and manipulating different state machine inputs, but we're going to skip over that for just a bit. And we're going to look at this return statement for this component. And so the markup here is a div that encompasses this canvas element. This canvas element is the entire viewport here, and we'll get into that. But I want to start here with this Rive button component. And this is, again, a self-made component here, so we're just going to jump into that. And this Rive button component is a lot simpler. And this is actually this bit here that it's rendering. So this explore text, as well as this start now Rive artboard and this link. And this will look similar to what we saw in the editor. So starting with this Rive button component here, you'll see that I'm importing two hooks from the Rive React runtime. I'm importing this use Rive hook, which is what I use to instantiate the Rive component itself. And I'm also importing this use state machine input, which is another nifty input that I can hook that I can use to grab a reference to a state machine input that like we saw from the editor. So starting off with this use Rive hook, I'm going to be passing in several parameters here that kind of instantiate Rive itself. And so this source property is important. This is where I pass in what the Rive file I want to load in is. And again, this is that reference to that Rive file from my public folder. So you can see the naming here matches up pretty appropriately. The hero use case v8.riv matches the name here. And because this is at the root of my web application, or it will be when I deploy the application, I can simply reference the Rive file this way. You can also pass in a URL if you decide to host this Rive file on your own CDN, for example. So there's a few different ways that you can reference the Rive file itself. The other important bits that I want to incorporate in this instantiation is the artboard, which is the name of the artboard here, which is button, and the name of the state machine. So in this case, it was state machine 1. I also want to set autoplay to true so that it's automatically plays the state machine when it's instantiated. And I also want to disable the Rive listeners here. And the reason for that is because we programmatically want to control that state machine input that we're grabbing a reference to is hover. Mainly because we are not going to be actually having any user interaction with the Rive component itself. We're actually interacting with this anchor tag, truly just overlaying that Rive component, the canvas, on top of this A tag, giving it the sense that it looks like a button, but functions like we're working with an anchor tag. And so you can see here we've got several different kind of event listeners that we want to hook up, such as on mouse enter and leave, and on focus and blur. And so let's take a look at what those use callbacks are doing here. Now we've got this on button activate and on button deactivate. And so we're going to be wrapping those in a use callback here. Before setting this is hover input, which again is a Boolean input like we saw in the editor earlier, to true or false, we want to make sure that these two variables have value. If we look at our event listeners, like on mouse enter or on mouse focus, we're going to be calling on button activate. And that's simply setting that state machine input is hover input value to true. And similarly for mouse leave and on blur, we're going to be calling on button deactivate, which will set the input to false. Now let's take a look at this Rive Hero component. Now this is a little more complex because we've got a few more hooks that we're going to be dealing with and a little bit more logic than that Rive button. Again, this is going to be the entire canvas that takes up the entire viewport and creates that cool backdrop that's really the star of this hero use case animation. Starting off, again, we've got that import from Rive App React Canvas, our React runtime, and we're going to be importing those two hooks that we were using in Rive button, which was use Rive and use state machine input. And we're also going to be importing 3 more things, which actually come from the Rive Wasm web runtime, which are layout, fit, and alignment, because as the window changes or our viewport changes in terms of size, we're going to be changing the layout a bit, as we'll see. Now we've also got a few utility hooks that we've got built into this project. One is use media breakpoint, and we're going to be using this to basically determine whether or not we've got a large viewport or not, or we're working with large screens. And we're also going to be using this use prefers reduced motion hook. And this is going to help us determine whether or not the user has set browser settings or system settings on their device to prefer reduced motion. Now, again, this component or this file only has one default component that it's exporting, so it's this Rive Hero component. So let's take a look at some of these state variables and what's at the top here. We're going to be wanting to track the last width and last height variables. These are number variables that we're going to be using with use state. And why we want to track those is because we want to track whether or not the viewport has changed in size as far as the width or height. And if so, we want to be able to scale the canvas element, which takes up the entire viewport, accordingly so that it takes up the new size. And we want to compare it with the last size to see if, hey, if nothing has changed, then don't worry about resizing the canvas. The other thing we have is we're going to be using that use media query hook that I mentioned. And so what we're passing in is essentially what looks like a CSS media query, only screen and min width 1025 pixels, which is going to help us determine if we're working with large devices or not. And again, we're going to be using the use prefers reduced motion hook to be able to determine whether or not the user prefers a reduced motion experience. Let's take a look at this block here. We are using our use rive hook just like we did with the rive button. And again, we're setting our source to be that rive file in our public folder. In this case, we're also going to be working with a different artboard, the Hero Demo Listeners Resize artboard. The state machine is also just called state machine 1. And to start with, I want to give it a default layout of a fit cover and alignment center. What fit cover will try and do is take the available space, all the available space of the canvas, both height and width-wise, while trying to maintain the same aspect ratio of the Rive graphic as it was designed in the Rive editor. This means as it tries to fill the amount of space, it may potentially crop out any bits or small parts of the Rive graphic in order to maintain the same look and feel without trying to skew or squish the graphic at all. Now I'm also passing in a second object into this use Rive hook, which are options specific for Rive React. Now I only want to pass in one option here, which is the should resize canvas to container set to false. Now what the Rive React runtime will do automatically for you is try to scale the canvas to its parent element. In this case, there is a DOM element that has a width and height of 100%. So really what this canvas is trying to do is fit itself to the container and scale itself appropriately. And as the container grows or shrinks, the canvas will resize along with it. And there's some internal logic to kind of make that coordination happen pretty smoothly. Now it might seem pretty unintuitive why we would want to set that to false, but really what we're going to be doing is recreating the same logic here, but adding in more custom logic behind the scenes. In this case, we're going to be manipulating a state machine input. Moving on, we've got this use effect block here, but essentially we want to look out for these variables rive and large query, and if they change, be able to change the layout accordingly. For example, here we're checking if it is a large if it matches that large CSS query, basically if we're on a large device, we want to set the layout to fit contain and center. Now, this is a little different than what we've instantiated. With fit contain, what it's going to be doing is it's not going to try and take up the entire height and width of the canvas itself. It will try and take up as much space as possible while maintaining the aspect ratio, but it will fit the entire Rive graphic. So that means there may be some kind of padding on the top, bottom, or left and right of the canvas, depending on how big the canvas is, but it will show the entire Rive graphic, so nothing will get cropped out. And on large devices, it probably makes sense that we can reliably show the entire Rive graphic without anything looking too small to interact with. Now, just to illustrate what I mean by this, take a look at this inspective debugger we've got in Safari. So you can see here, we're showing the entire Rive graphic in its whole state. So there's nothing cropped out here, and it's taking up what it can from the canvas space. The background happens to be the same background as the canvas, so it makes it look like it's seamless and that really the padding is just part of the background, this kind of black color. But as we start zooming or cropping the viewport a bit and moving it in, you can see that the Rive graphic jumps, and now it's trying to take up all the available space of the canvas. That's that cover state. So what we were seeing here, which is anything above 1025 pixels, it's going to be in that fit contain state, which is going to show the entire Rive graphic, but only show it in the amount of space that it needs on the canvas while maintaining aspect ratio. And in fit cover, it's still maintaining the same aspect ratio, but it's taking up the entire space of the canvas as much as it can and cropping out any parts that don't fit. So you can see that parts of this don't fit perfectly, and we'll take a look at how we can address that. Moving on from the layout side, we've got these usages of the use state machine input, and we're going to grab 3 references to those 3 state machine inputs that I was looking at earlier in the editor, which was that numx, numy, and numsize input, all number inputs. The only difference in how we're using this compared to how we were using it in the Rive button is that we're passing in a 4th parameter here, and that's the value that we want to instantiate it at. And so in this case, we want to start the value for that number input for num x and y at 50 and num size at 0. Next, I'm going to be looking at this use effect with prefers reduce motion, that variable that we're going to be looking at. This comes from, again, that use prefers reduce motion hook that we're calling in the beginning here. And essentially what we're doing is we're listening for whether or not this value is true. Because if it is true, we're going to pause the animation via that rive object we get from useRive. Again, this is that central object that gets returned and is where we're going to be changing the layout from, we're going to be calling pause or play from, and things like that. And so we want to pause because we want to stop the animation and just pause it at the current frame to give people who prefer reduced motion a more pleasant experience. And we're going to skip over this resizing logic a bit. This is kind of a larger use effect block, and move straight into the return statement. So as you can see, we have that rive button that we were working with a bit earlier. So we're just going to be rendering that on top of our canvas. And this is an absolutely positioned element, so it's just going to be centered in the center of our screen always. And we have this div element that's kind of encompassing everything, and this canvas element. Now, normally what we'd be able to do is just return that rive component from use rive here. But as you can see, we're not actually extrapolating any rive component from the return of this use rive. Instead, what we're going to be extrapolating are these set canvas ref and set container ref callbacks. And what we'll do here is essentially set the container ref on this parent div and that set canvas ref as a ref attribute on the canvas element. Now, behind the scenes, the rive component that we would have normally exported from useRive, it's essentially what this markup looks like. It's a div with an encompassed canvas element here. So using the set container ref and set canvas ref ref callbacks that we get from useRive, we can set those as ref attributes on the parent div and canvas child ourselves. And this way we have full control of that parent div element as well as the canvas. And we'll see how we can basically copy over that resizing logic that we use in the Rive React runtime under the hood while adding some custom logic in. And now we're going to be taking a look at how we can achieve that effect of the view changing with our cursor movement here. If we take a look at that parent div element, we've got this on-mouse move event handler that we're going to be attaching to it. And again, this div element is spanning the entire viewport, height and width-wise. So we're going to be passing it this on-mouse move callback, where we get this e variable, which is a mouse event. And this mouse event will tell us basically the coordinates of our cursor on that div element. You can see here what we're starting with is the inner width and the inner height. We're grabbing references to basically the max width and height there. We want to basically take the cursor x value and take it as a percentage based on the max width of our viewport. And we're going to be multiplying that by 100. So basically we're getting a percentage of where our x axis for the cursor is as a percentage. And consequently, we're doing the same thing with y, but we're going to be doing 100 minus that because our y wants to work in a different direction here. So moral of the story is we are trying to get values or percentages of where the cursor is from 0 to 100% for both the x-axis and the y-axis on the viewport. And we are setting those as values to the numx and numy state machine inputs here. Again, these variables come from that state machine or the use state machine input hooks. We get those references here, and all we simply have to do is set the dot value to whatever new value it is. So this is constantly updating as our cursor moves. So now what we want to look at is how this canvas is scaling with the viewport as it shrinks or grows that window. And so again, as we grow this window, you can see the canvas isn't remaining stagnant. The content is actually growing with the viewport as we grow or shrink the window size here. And that might, again, look counterintuitive because we said, hey, in useRive, I'm going to set this should resize canvas to container to false, which means we're going to be maintaining and maintaining our own resizing logic ourselves, which is going to be this larger use effect block. So let's dive into this. So the core function of this use effect block is really to say, hey, if this parent div container that's taking up the entire size of the viewport changes size due to a browser resize or whatever it might be, we want to listen for that resize event and scale the canvas accordingly with it. And there'll be a bit of extra logic in there regarding a state machine input, but that's really the goal of this. Now we're going to want to work directly with the DOM elements themselves. In this case, we really want the refs to this div element and this canvas element so that we can manipulate the CSS style, width, and height of the canvas, as well as some of the attributes on this canvas as well. Now, going back to this, we set these ref callbacks on the ref properties for the div and canvas, but really what we need is the actual ref element itself so we can work with the DOM elements to get their actual size and things like that. And so to get access to those, we can actually get that from part of the return from useRive. So along with that set canvas ref and set container ref, where we're setting the ref for the canvas and container, we can actually get the values of those refs itself, which are the DOM elements, via the canvas and container named return properties from useRive. In this case, just to make it a little clearer what we want the canvas ref and the canvas container ref, or rather the canvas element and its parent div element here. So going back to that use effect block, first we're checking, hey, is Rive instantiated? Is our canvas and its container rendered into the DOM? And if so, we're going to create a new resizer observer. And this resize observer API is essentially saying, hey, when you attach me to a DOM element, I'm going to execute some logic for you automatically. And so we're creating this resize observer and attaching it using the .observe property on the canvas container ref. In this case, that's that div element that takes up the entire space. And the space is basically CSS of saying width 100% and height 100%. So anytime that changes in pixel size or whatever it might be, we're going to execute some logic within this resize observer. So taking a look at the logic that we want to execute every time that div element resizes, the first thing we want to do is we want to grab the new width and height of that div element. So if the window resized and the div element resized accordingly, we want to get that new width and height because we're going to scale the canvas accordingly. Skipping down a bit here, the way we're going to be scaling that canvas is, as you can see, setting it to that new width and height in pixels. In this case, we're taking that style property and we're going to manipulate the actual stylistic height and width of that canvas and just add pixels here. So we're going to set it to the same size. The other thing that's important here, though, is we need to set the width and height attributes of the canvas itself, which is a little different. The width and height attributes on a canvas element, different from the style width and height attributes, help dictate the actual surface area of the canvas and the amount of pixels inside that canvas element. And this is important that we take the device pixel ratio into account. You can get this from the window API and grab that property. So this is going to be a number. And for example, on high retina devices, that number may be a multiplier of 2. So for example, if the width and height style properties of the canvas were 500 by 500, but the device pixel ratio is set to 2 on high retina displays, you may need to set the surface area to be twice the size of that area. So in this case, the height and width would be 1,000 by 1,000 instead of 500 by 500. And that may vary just depending on which display you're going to be rendering the canvas onto. And probably the last thing to note here is that we want to compare the last calculated dimensions with any new dimensions in case the resize has occurred to make sure that we only resize the canvas if the dimensions have actually changed. There could be other things that trigger the use effect to take place, which means if any of these variables change for any reason. So it's just a good fallback and a safeguard to make sure that we're only resizing the canvas if we need to. And the last thing we want to revisit here is this num size business. So just to refresh, the num size is a reference to a state machine input called num size that starts at 0, and we're grabbing that using that use state machine input for the state machine. And really what we're saying here is between the 500 to 1200 pixel range, once our devices start to get in that range, we want to start to scale that window back. So for example, here in my browser, as I start to scroll down, I want to be able to manipulate this num size input such that the helmet's narrowness is kind of scaling with us. Even though it's not really respecting browser boundaries, we can still kind of get that effect that, hey, it's constrained to the browser width size here. So the calculation I really want to set for this num size.value here is, well, between that 500 to 1200 pixel range, that's about 700 pixels of a range I want to get here as the denominator. I want to figure out how close is it to 500? And the closer I am to 500, the closer I am that this value is going to be 100%. If it's closer to 1200, I want this to be closer to 0%. Essentially, as the viewport gets smaller, the num size value should increase. And so we're just trying to get a percentage based on the current new width that the div has resized to, try and figure out, where in that range it lies, so that we can constrain that helmet view that we're seeing with the viewport. And so because we have this custom logic here with our custom resizing logic that we've got real implemented here, this is the reason why we needed to set the should resize canvas to container flag option that we pass into useRive as false, because we wouldn't be able to otherwise inject this custom logic of every time the container resizes, watch to potentially set this num size value state machine input. So if you have a similar situation in your applications, if you're using useRive and you want to inject some custom logic when you are resizing the div container, this is a pattern that you can follow as well. And the only other thing to mention here is that we've got these two APIs that we're calling in our resize observer, which is rive.resizetoCanvas and rive.startRendering. And essentially what these two APIs are doing is syncing the Rive layout to the new dimensions of the canvas. So if the new dimensions of the canvas have changed, we want to ensure that Rive is notified that the layout has changed as well. And the layout has references to the min and max x and y coordinates of your canvas. And so this basically tells the renderer what bounds to draw Rive onto for your canvas. And if the bounds have changed, which most likely will in this scenario, we want to make sure that Rive is notified of it. So we call these two APIs to ensure that the layout is updated as well. Hopefully this tutorial was insightful in understanding how you can build your own hero animations for your websites and web applications. Of course, this is a little more of a simpler demo, but gives you a good idea of how to make sure that your canvas scales accordingly with the browser, with other devices, and potentially how you can even format your Rive file to work with different kind of devices for a more flexible layout. I definitely encourage you to check out the other past design videos for how we built out the design and state machine in the Rive editor for this use case. Thanks for watching. If you have any questions, feel free to reach out on our Discord community where you can ask questions about this video, how the state machine was set up and designed, or other potential questions about hero animations for your websites and web applications. And also feel free to check out any of our other use case videos to get a sense of how you can use Rive in other platforms as well.